Please calculate these percentage changes.
Okay, so for a warm-up, I want you to perform the following calculations. I want you to increase £50 by 12%, i.e. the total amount of money after it's been increased, and following that, I want you to decrease £80 by 25%. I'll just give you a few seconds to see if you can calculate the first one. Okay, thank you. Now what we have in front of you is a proportion table. This proportion table is simply two columns, the percentage on the left and the pound sign in the right. Now the original amount of money on the first question is £50. Now the original amount of money is all the money that we have so far, which of course is the full amount. And the full amount is a percentage, 100%. Now we want 12% more. We want to increase it. What is 12% more than 100? 112. So now we have a proportion table with just one gap, and that is our answer. What do we do to calculate that gap? Well, we use what is known as the divide multiply horseshoe. And the reason why it's such is because you follow around the horseshoe in the shape that you see. So you divide first of all, then you multiply, and then you press equals on your calculator, and that should come up with the answer. Hopefully you will type in your calculator 50 divided by 100 times by 112, and that gives you £56. Your answer to the first question is £56. Now the second question is decrease £80 by 25%. Again, proportion table, percentage on the left, pound on the right. The original amount of money is £80, which is the full amount of money, so the original full percentage is 100% always. What is 25% less than 100%? Well, 25 from 100 leaves you 75%. If you're decreasing or reducing by 25, you've got to take the 25 from the 100. The same as before, the divide, multiply, horseshoe. D for divide, multiply, M for multiply. 80 divided by 100 times 75 on your calculators should give you £60. Now that's a warm-up for the main teaching point of today's video. We're going to look at compound interest, which of course is an actual simulation to how money grows at banks. You may have heard of what's called simple interest, which is a rough calculation for working out how much money you'll have if you put a saving into a HISA account over a few years. But really, the compound interest is the more accurate model.
I put £1 million into Santander Bank. The interest rate each year is 3%. How much money will I have in 1 year?
Thank you, Rory. Okay, so we've got £1 million as our starting amount. We're increasing by 3%. In 1 year's time, there will be one calculation because, of course, the 3% increase only happens at the end of each year. Now, the full amount, of course, the table, may I remind you, percentage on the left, pound on the right. The full amount is £1 million, and of course a full amount is expressed as 100%. Increase means more or go up. What is 3 more than 100? 103. So now we use our DM horseshoe, and the calculation as follows, that you'll type into your calculators will be 1 million divided by 100 times 103. And that gives us £1,030,000. So Rory McGrath has put £1 million in the bank, but in a year's time he's increased by £30,000.
With this 3% increase, how much will I have in 2 years' time?
Now of course 1 year's passed and he likes the rate of interest that he's gaining from having it in his savings account, and he wants to know how much money he'll have this time next year. Again, another proportion table, percent on the left, pound on the right. 100% is on the left because that is the full amount of money of which he has now, presently, a year later. And how much money does he have? Not $1 million anymore, that was the old amount. He's got 1,030,000. The increase is still 3% because the bank rate hasn't changed that for this example. What is 3 more than 100? 103%. Exactly the same as before, the DM horseshoe. £1,030,000 types into your calculator, you'll divide that by 100 and then multiply your answer by 103. You can press equals after this calculation and then times 103, or in this example it would work if you do it as one full step. With your equals button, you've now got £1,060,000, sorry, £1,060,900, a £60,900 increase from when he originally invested his 1 million 2 years ago.
That's great, but I had to use two calculations. If I put £1 million in the bank, can I calculate how much I'll have in 2 years' time using only one calculation?
Now that's a valid point. Two calculations wasn't too long-winded, but what if the question was something like 7 years' time? Could you invest all the time in your exam to sit there and produce 7 calculations? Or is there a shortcut? Can we just have one step, one calculation to type in the calculator? Well, it's very similar, the calculation is very similar to what you had before, where you have the original amount of money, £1 million, you divide it by the 100% and multiply by the 103% because the 103 represents 3 more than 100. But look, you've got to the power of 2, or squared, on both the percentages. That power of 2 signifies that we want to see how much money in 2 years' time. Be careful when you type this in the calculator. And you should get the same answer, £1,060,900. Do make sure that your calculator produces that answer quickly if you haven't done so already.
My bank pays 4% interest each year. If I place £200,000 into the bank today, how much money will I have in 9 years' time?
Well, Lee Westwood seems to be banking with the Bank of Yorkshire, if such bank exists. Okay, so £200,000 is the starting point. He wants the bank to pay him 4% extra increase. What is 4 more than 100? 104. So he's got his £200,000, he divides by his 100% with a power and multiplies by 104% with another power. Why are we using to the power of 9 on both the percentages? Because the 9 represents how many years need to pass for the full amount to represent his answer. Okay, the 104 represents 4% more than 100%. The power of 9 signifies 9 years. This picture shows the calculator, or one that you'll be using which may be similar to this, x to the power of something. When you press that button, it will show you that you can express the calculation using to the power of 9. That is the power or index button. Please type in your calculator and you'll find hopefully that the calculation will produce £1,423,311.81 to 2 decimal places. You'll find that 2 decimal places may not be on your calculator screen, but of course, whenever we're dealing with money, always round your answer to 2 decimal places. Now that is a lot of money, considering he started off with only £200,000 a year ago. 9 years ago.
My bank pays 3.6% interest each year. If I place £50,000 into the bank today, how much money will I have in 15 years' time?
Okay, so the original amount of money is 50,000. We're going to divide by 100% with a certain power to a certain power. What is 3.6 more than 100? You should agree it's 103.6. And of course, do be careful with your to the power of 15, because that represents how many years we're going to invest for. To remind you, 103.6 represents 3.6 more than 100%. Interest always means that you will get more or pay more. The power of 15 represents 15 years. Punch that in your calculator. Be careful to use the correct index button. It may be slightly different than your calculator. I will give you a few seconds to punch that calculation in, and then we'll see if we agree answers. Be careful, so 2 decimal places, we should have £84,989.71 in Lewis Hamilton's bank in 15 years' time.
I'm selling this car for £1,500, but don't tell the customer that it loses value or 12% each year. How much would a car be worth in 7 years' time?
Of course, this strategy doesn't just work for compound interest, i.e. increasing in financial amounts. Cars lose value over time. The word is depreciate value for those that are doing business or economics. The car will depreciate value in time. Now, Max Brannan has managed to sell this for £1,500 rather, 1,500, and he predicts that every year it will lose value or depreciate by 12%. How much will it be worth in 7 years' time? Well, we're always going to divide by 100% to a certain power. That is because the 1500 is always the full value. 100% is always the full value. But what you need to know is, what is 12% less than 100? You should agree that it's 88. So the calculation is 1500 divided by 100 to the power of 7 times 88 to the power of 7. Always read the question properly. How many years' time are we looking at? How many years' time are we interested in the value of the car? The 88 represents 12 less than 100, and the 7 signifies 7 years. I'll let you type in the value of the calculation, correctly using the index button in 2 steps of the calculation, and hopefully you should find an answer which is significantly less than £1,500. £613 and a penny, which is less than half the value over 7 years' time. Be careful, you may have found an answer which is greater than 1500. That means that you might have used a calculation, typed in a mistake on your calculator. Remember, you're dividing by 100 and timesing by the 88. Check the question. The car is losing value. Your answer must be less. Before the money is gaining in interest, your answer must be more. If your answer seems smaller than the question in the interest question, or if the answer seems bigger on the depreciation question, you may have typed in the times and multiply the wrong way round.
Excellent.
I will leave you to practice answering these questions. The presentation will end here, but leave the screen as it is so that you can practice these questions for yourself.